Today we're going to look at Kotlin's ever-elusive anonymous function. As you probably know, Kotlin gives us a few different ways to write functions. The first, of course, is to just declare a named function with the fun keyword like we're doing here. And named functions can go inside classes, they can go at the top level, and they can even go inside other functions. A second way to write functions is with a lambda. Now, a lambda uses a more concise syntax compared to a regular named function, and it has the advantage that it's also an expression. So you can assign it to a variable like we're doing here, or we can pass it directly to a function. Now, there's actually a third way to write functions in Kotlin, which isn't as well known. And in fact, you could even work with Kotlin for years and not actually come across it in the wild. This third syntax is called an anonymous function. Now, if you've got experience with other programming languages, you might be used to thinking of lambdas and anonymous functions as being the same thing. After all, a lambda is nameless. Like, sure, you can assign it to a variable, but the function itself is declared without a name. And since it has no name, it technically fits the regular English definition of the term anonymous, which means that it has no name or its name is unknown. But when we're talking about Kotlin in particular, an anonymous function is distinct from a lambda, and it has its own syntax. So here's how it looks. An anonymous function is written the same way as a named function, but you just omit the name. So for example, we can take the same code that we had up here and just paste it into our main function, and then remove the name. Now, when you do this, you see that we get this warning in the IDE, and that's just because we've got this unused expression. And that's because, like a lambda, an anonymous function is also an expression, so we can just assign it to a variable, and we can also pass it to a function, a lot like the lambda above it. So in terms of its characteristics, an anonymous function sits kind of somewhere between a lambda and a regular named function. It's an expression like a lambda, but it also bears a number of similar characteristics to a named function, as we're about to see. One big difference from a lambda is that the return keyword works the same in an anonymous function as it does with a named function. So for example, let's say we need to start handling invalid input. Well, we can update our lambda and anonymous functions so that they short-circuit the case where the line doesn't contain a valid key value pair. But this is where we start to notice the differences. With a lambda, we get a compiler error, but with an anonymous function, this code compiles just fine. Now, as you might recall, in Kotlin, we don't use return inside a lambda to provide its result. Instead, the result is simply evaluated as the last expression in its body. So one way of removing this compiler error that we see is to change the process list function so that it's inline. And even though this compiles, we might be surprised with the result. So even though we have two calls to process list inside this main function, one for the lambda and one for the anonymous function, this code actually finished running before it finished processing even the first list. So let's comment out the lambda, and let's see what happens with this now. And this time we see that the anonymous function was run for each line. So with the anonymous function, this return just short circuits its own execution. But with a lambda, this return actually returns from the main function. So if you need a local short circuit, anonymous functions might be a more natural choice. Now, there are some workarounds for the lambda. So for example, we can add a label to the lambda and then use that label when we return. And this time when we run it, we'll see that we get the same output for both the lambda and for the anonymous function. And in fact, this approach works also without inlining the process list function, so we can remove the inline there. And when we run it, we'll see the same output again. Now, as I mentioned earlier, the result of a lambda is usually the last expression of its body, but an anonymous function operates more like a regular named function where you'd have to actually return the value. So here I've got two functions that split a line into a key value pair, one implemented as a lambda and one implemented as an anonymous function. And even though their bodies are the same, when we run this, we see that the results are different. So just like with a regular named function, if we want to return that last expression, we have to add the return keyword to the end of the anonymous function and then actually declare its return type. And now when we run this, we get the result that we expected. So we had to add a return type here, which brings up another difference with lambdas. You can't specify a return type in a lambda expression itself. So for example, if we want to return the result here as a serializable instead of as a pair, we can easily change the return type of the anonymous function. There's nowhere for us to put the return type in a lambda expression though, so instead we have to specify it on the variable that it's being assigned to. As you probably know, when we explicitly specify the type of a variable, we can let Kotlin infer the type of the lambda's parameter, so we can remove the parameter's type here. Well, anonymous functions allow you to do the same thing. So if we specify the type explicitly, like we did above, then we can remove the type of the parameter in the anonymous function like this. That type is optional and it can be inferred. So again, anonymous functions have some characteristics of named functions and some characteristics of lambdas, but we'll put that back for now. So we saw how an anonymous function can explicitly specify its return type. Well, similarly, if we want our function to have a receiver type, we can add it directly to the anonymous function. If we want to do the same thing for the lambda, we again rely on the type of the variable that it's being assigned to. And by the way, so far in this video, our anonymous functions have had block bodies, but we don't have to use a block body with an anonymous function. So here you can see I'm using an expression body with an anonymous function. And even though we might expect these two equal signs to confuse the compiler, this actually works just like you would expect. So an anonymous function kind of sits somewhere between a traditional named function and a lambda. It behaves like a traditional function, especially with regard to its syntax, the way the return keyword works, and the way that you have to specify its result types when you're using a block body. On the other hand, it's also an expression, so it can be used in the same contexts as a lambda. And like a lambda, you can omit its parameter types if they can be inferred. Now, the big question is whether there's anything that we can do with an anonymous function that we can't do with a lambda. With workarounds like labels or specifying the types of the variables that they're assigned to, I haven't discovered any cases where an anonymous function was the only solution, which might be why we don't often see anonymous functions in the wild. So if you know of any cases that I haven't thought of, situations where you would have to use an anonymous function instead of a lambda, definitely let me know in the comments because I'd love to hear about it. Well, that's going to do it for this video. Remember, new videos are published on this channel every other Wednesday, and to make sure that you catch them all, you can of course subscribe to the channel, and you can also join hundreds of other Kotlin developers who have signed up for my email newsletter, and you can do that at newsletter.typealias.com. In the meantime, keep writing that Kotlin code. Thanks so much for hanging out with me today, and I'll see you next time. Warm up the winter with some Type Alias merch. Find your favorite characters on mugs, notebooks, and stickers, and grab some PDF cheat sheets to keep your coding fast. Stack up the merch and heap on the savings. Use promo code WINTER20 for 20% off through the end of the year. Just go to shop.typealias.com.